Yeah, good everyone. Today we are looking at set theory. When they say set theory, what is a set? What is union of a set? What is intersection of a set? And what is cardinality of a set? Actually, there are so many other things about sets that used to be asked, particularly the kind of question, how the examiner said the question. But maybe by the time you are solving another question on this one, you get to know to meet some other things that can be asked on the set theory. But for this particular one, we are going to look at all this one. But before we, after this one, then there is always a given question to solve on the set, any given set theory examination. Now, like this one, we say given the unifier set is x plus 1 less than or equal to x less than or equal to 20. So what it means here is that unifier set is 1 to 20. That is what it simply means. Whenever you see something like this, we say set A is 1, 4, 5, 6, 7, 8, 9, 10, 11, 18, 20. Then set B is 1, 2, 7, 8, 9, 12, 13, 15, 18, 20. Then find, that is the question that we're doing. Then find A complement, then 2 A union B complement, then 3 A complement intersection B complement. Then that is one question on its own. Then another one says that in a class of 80 students for an examination, 34 students over business maths, 29 students over economics, while 42 students over accounting. Yes, while 42 students over accounting, 12 over business maths and economics, 14 over accounting and economics, and 8 over business maths and accounting. 4 students do not over any of the 3 subjects. Now how many students over all of the 3 subjects? How many students over combination of 2 subjects? This particular question, when you want to solve it, you'll be needing Venn diagram. They call it Venn diagram. That is what it can be used to solve this question. Venn diagram, where we'll be having in form of square. This square will represent unifier set. Then we now have 3 circles, where these 3 circles will represent each of the subjects. Like here we have business math, economics, and accounting. This one will represent business math, accounting, economics. Then we now know how many students over 2, how many students over this and this, how many students over the 3. By the time we get to solving of that, we are going to get it better. But first, let's try to understand what all these are, all the part. When they say a set simply means a collection of well-defined objects or things. That is, a collection of objects or things that have something in common. Collection of objects that is, a set is a collection of a well-defined object or things. That is, collection of objects or things that have something in common. When we say a set, it's not just collection of anything. Like the set must be collection of something that has of objects that have something in common. Like e.g., when we say set A is equal to, let's say 1, 2, 3, 4, 5, 6, 7, and so on. Or the set is Monday, Tuesday, Wednesday, and so on. Or it could be Tola, Bolu, Lade, and so on. If you look at all this, you see that they are collection of something, they have something. You know, all these, they are numbers. They have something in common. All these, they are days of the week. They have something in common. All these are name of people. They have something in common. Not that now say $1, Tuesday. No, that is not a set. A set must be collection of something that have of an object that have something in common. So that is all about what set. What's all about? Then we now be looking at when they say union of the set. Union of the set. Union of the set simply means that the element that can be found in either of the given sets. Element union of a set the element that can be found in either of the different sets. That is the joining of two or more given sets without repetition of an object, of an element. So what you mean by union of a set is that when is element that is common in two given sets. That is, in example, to get it better, the fact about this thing is that whenever you are doing it, when you define something, like you try to make example to make it clear for the examiner that you really know what you are solving. Now when they say that union of a set, for e.g., let's say a is set A is 1, 2, 3, 4, 5, 5. Then B is 1, 3, 5. Now when they now say union of, okay, let me put it like this. Let me see. 7, 10. Then this one have 8, 9. Now when we see e.g., they say that set A is 1, 2, 3, 4, 5, 7, 10. Then set B is 1, 3, 5, 8, 9. When they now say union A union B, A union B will now be, that is, if you look at the definition that I give you, that is the element that can be found in either of the sets of the given sets in either of the given sets. Now when they say A union B, now will now be, we join all the elements in this thing, we join it together, but we are not going to repeat anyone. Like here we have 1, here we have 1. We are not going to say 1, 1. No, 1 is 1. Here we have 3, here we have 3. We are not going to say 3, 3. No, it's 1, 3. So all the elements that I said we list it, all the one that I said we list it. That is what they mean by union of a set. That is why I said that the joining of two or more given sets without repetition of an element. Now A union B now is now going to be 1, 2, 3, 4, 5. There is 5. There is no 6. So there is 7. 7, 8. Then there is 9. There is 10. 9 and 10. Now this is A union B. So that is all about when they said union of a set. Now intersection of a set. When they say that intersection of a set, that is intersect. When they say intersection, intersect, that intersection of a set. When they say that intersection of a set, it simply means that, let's look at the word intersect. Means that when two things join, that is, intersection of a set simply means that the elements that are common in two given sets, that is, the element that can be found in two given sets, is different from union of a set. Union of a set simply means that we are going to joining of the two given sets, of the element of the two given. But this one is intersection simply means that we are going to pick out the element that can be found in two given sets. So when they say that intersection of a set, simply means that these are the elements that can be found that can be found in two given sets. So of the sets. Elements that can be found or that are common in two given sets. So that is what they mean. Now, e.g., let's say set A is equal to neutral number 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then set B is equal to odd number 1 to 10. Odd numbers is 1, 3, 5, 7, and 9. Now, when they now said A intersection B now will now be A intersection B. When they say A union, A intersection B is A union B. A union B is A union B. Now this one, A intersection B, will now be. Now you say that is an element that, or let's use the word D, is the element that can be found or that are common in two given sets. Now, what are the elements that can be found in two given sets or that are common in two given sets? Here we have 1, we have 3, then we have 5 here too, then we have 7, and we have 9. So approximately all these ones are also common in this one, so they are intersection. Though because I use this example, there are some that in the case that they gave, the kind of element they gave as a B might be wider than this, that normally supposed to be wider than this, that it's not just that the intersection will not be everything that is here. So I just use this one as an example, that A union B simply, A intersection B simply means that the element that can be found in two given sets. So like if I want to expand this one now, I might say, to make it clear more, I say this one also have 11, 13, 15. Now, okay, let me put it like that. So now A intersection B now will now be any element that can be found in two, now be the intersection, that where they intersect, where they meet, they have 1, 1, they have 3, they have 5, they have 7, then they have 9. This one have 8, this one doesn't have. They have 10, doesn't have. This one have 11, doesn't have. This one have 13, doesn't have. This one have this one. So assuming it's A union, you know that everything that is there will be put in that union set also. So this is all about the intersection of the sets. Oh, pause it. Now, cardinality of a set. What is cardinality of a set? Simply means the number of the elements in the given set. That's just it. Number of elements in in a given set. That is, e.g., let's say set A is equal to, we have 1, 2, 3, 4, 5, 7, 9, 10. Now the cardinality will now be 1, 2, 3, 4, 5, 6, 7, 8. Or we said A is equal to Tola, Tolu, Tope, Bose. So the cardinality will now be 1, 2, 3, 4. That is number of elements in a given set. That is what the cardinality means. Actually, there are so many other things that they used to ask about the set. Actually, after this one, we are going to look at another question that may ask similar things. But before then, in case you have some other things to ask about this concerning this, you can reach me on my WhatsApp number, which is 08164031819. Then please don't forget to like and subscribe to this YouTube page, so that whenever we drop the video, you are going to be notified directly. Thanks. Now, after explaining what this about, then we can now go to the main work of today, which is calculation aspects. Because every given set theory must always have a calculation aspect. Now we are starting with this one. The other given unifier set is x/1 less than or equal to x less than or equal to 20. Whenever you see something like this, know that this one less than or equal to 20, that means 1 is neutral number 1 to 20. That is what it simply means. Now, then they say that they now give us the set A to be this, then set B to be this. Now the first thing is to list out the unifier set. Now unifier set is equal to, it say 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now that is unifier set. Now given that A is equal to, then A is equal to 1, 4, 5, 6, 7, 8, 9, 10, 11, 18, 20. That is A. Then B is equal to 1, 2, 7, 8, 9, 12, 13, 15, 18, 20. Now the question now say that question one say that A complement. What is A complement? A complement. Question one say that A complement. Now this will take us to when they say that complement. What is the complement of the set? Complement of the set simply means that the elements that can be found in the universal set which is absent in a given set. That is what they mean by complement of a set. That is when they give you, but when they give you, before they can add something like they give you universal set like this one now, that universal set is neutral number 1 to 20. They now say the complement of set A, which simply means that the element that is in universal set that is not in set A. That is what they mean by complement of a set. Now the complement of set A now will be, what are the things that is in universal set that is not here? here in universal set we have 1 to 20, right? That means any number from 1 to 20 that is not here is complement of a set A. We have 1, 2 is absent, 3 is absent, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, 9 is there, 10 is there, 11 is there, 12 is absent, 13 is absent, 14 is absent, 15 is absent, 16 is absent, 17 is absent, then 18 is there, 19 is absent, then 20 is there. That means these are the complements of set A. That is the element in the element in the universal set that is not in set A. That is complement of the set A. Then that is the first one that I asked. Then the question 2 says that A union B complements. A union B complements. A union B complements. A union B complements. What they mean by A union B complement simply means that we are going to unite A and B. Then we now find the complement. That is, when you find the union of A and B, you now find the complement of that union of A and B. So the first thing, when you see A union B complement, first thing is to find this one first. So now say first look for A union B. Now say this marker is rectangle, so now say
the thing
is to find A union B. First look for A union B. Now say A union B is equal to, I said it earlier that A union B simply means that you will unite, you will join all the elements in A and B without repetition of one of single element. Now A union B, we have 4, we have 1, we have 2 here. There is no 3 in both, so we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 9, we have 10 here. We have 9, we have 10, we have 11, then we have 12, we have 13. Is there 14? This one doesn't have any. There is no 14. There is 15. There is no 16. There is no 16. There is no 17. There is no 17. So we have 15. There is 15. There is no 16. There is no 17. We have 18 and 20. We have 18, then we have 20. That is union. That is A union B. That is all the element that is in union in set A and set B. We join them, joining of two sets without repetition of one single element. That is all the main element that can be found here and here. We unionize them. That is what we do. Now after when we got in our A union B, now we can now get the A union B complement. That is A union B complement will now be all the elements that can be found in unifier set that is not here. That is what simply means by A union B complement. Now said A union B complement is equal to, yeah, there is 1, there is 2, there is no 3, there is 4, there is 5, there is 6, there is 7, there is 8. A union B complement will now be anything that is in unifier set that is not here. That is A union B complement. Now in unifier set, we know unifier set to be 1 to 20, right? So any number from 1 to 20 that is not here is A union B complement. Now here we have 1, there is no 3, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There is no 14. There is no 14. There is 15. There is no 16. There is no 17. Then there is 18. There is no 19. Then there is 20. Now, so these are our A union B complements. So with this, we answer this question also. Now, Now A complement intersection B complement. A complement intersection B complement. When you see something like this, that means we first find A complement, then we find B complement before we now find their intersection. So that is how they solve this kind of question. Now, the first thing is to find A complement, which is anything that is in the unifier set that is not in set A. So, which is we have 2, 3, we have 4, 5, 6, 7, 8, 9, 10, 11. There is no 12, there is no 13, there is no 14, there is no 15, there is no 16, there is no 17, and there is no 19. So that is A complement. Then B complement. B complement anything that is in unifier set that is not here. So we have there's 1, there's 2, there's no 3, there's no 4, there's no 5, there's no 6, there's 7, there's 8, there's 9, there's no 10, there's no 11, there's 12, there's 13, there's no 14, there's 15, there's no 16, then there's no 17, there's no 19. So that is A B complement. Now, going back to the question that A complement intersection B complement, you can now say that since we've gotten our A complement and B complement, then you can now find that A complement intersection B complement, that is any element that that can be found in both sets. That is now A complement intersection B complement. A complement intersection B complement is equal to what can be found? 3 can be found in both. What else? 3 can be found. 14 can be found. 14 can be found. 16 can be found. 17 can be found. 16 can be found. 17 can be found. Then 19 can be found. So that is all about A intersection B complement. So it's not set theory is not something that is somehow techniques like that. So with this we solve anything or what they ask about this one. So if you see any other similar thing that you want to get clarified, I've stated my number earlier, my WhatsApp number. Reach me there. You can simply get in touch on that. Now we will be going to the main calculation whereby we'll be using Venn diagram. This particular question, this is one of the questions on set theory that is just a little bit techniques. We said in a class of 80 students for an examination, 34 students over business, 29 over economics, while 42 over accounting, 12 over business and economics, 14 over accounting and economics, and 8 over business and accounting. 4 students do not over any of the 3 subjects. Now the question says that how many students over all of the 3 subjects? Then question 2 says that how many students over combination of 2 subjects? Whenever we are being given this kind of question, the first thing is to list them in the form of sets. That is, they said in a class of 80 students, that means 80 is the universal set. Now say universal set is equal to 80 students, where they said 34 students over B smart. They said B smart will be represented by B. I said B is 42. Then 29 over economics. You say economics 29. And they say that why 42 over accounting. Now say accounting will also be represented by A. Accounting is what? 42. No? 34. Okay, Bismarck is 34, while accounting is 42. Accounting 42. Why 42 over accounting? That is, set accounting set is 42. They now say 12 over Bismarck and economics. It will now be Bis intersection E, Bismarck and economics, equal to 12. Then they say 14 over accounting and economics. That is, accounting intersection economics is equal to 14. Then 8 over Bismarck and accounting. That is, Bismarck intersection accounting is equal to 8. And 4 students do not over any. Now say 4, that is mean set is equal to 4. 4 students do not over any. So this is the first step. You list them out in form of set theory. So after listing them out like this, you now be very easy. This is the first step. Once you listed them out in form of set like this, so it will now be very easy to compute them using the Venn diagram. So that is the next thing we are going to be doing now. So after list them out in form of set like this, then we are going to be using Venn diagram to analyze it, to know where the two subjects join, where the three join, then to know how to calculate what we are given to calculate. Now, Venn diagram simply means that we'll be drawing a rectangle object. So after listed them out like this, then we draw a Venn diagram, which means this Venn diagram is representing the universal set. So now say universal set is equal to 80, right? And the subject we are talking about here is 3 subjects, which is Bismarck, economics, and accounting. Then we'll be drawing 3 circles like this. Then we have another one like this. So these 3 circles, each of them are representing, okay, for the clarification, let me use different markers so that it can be well understood. So we said, let me find another marker to use. Then we said, now you can now say that each circle are representing, you know, we have 3 subjects that we are talking about here. We can say this one is Bismarck, which is Bismarck is equal to 34. Then this one is representing economics, which is 29. Economics, which is 29. Then this one is representing accounting, which is 42. Accounting, which is 42. Then you should not forget that they will have students that doesn't over any, so they will not be in any category, but they will still be within the universal set, and this is universal, so we have 4. That is students that will not over any of the subjects. So now this is Bismarck, this is economics, and this is accounting. Now Bismarck, people that over Bismarck alone. Now, so for us to know people that over Bismarck alone is yet to know. We can represent that one by, let's say A. People that represent that over economics alone, they are yet to know. Let's say we represent it by B. Then people that represent over accounting alone, they are yet to know. We say we represent it by C. Now, people that over the 3 subjects, they didn't let us know that people that over 3 subjects also. So we said that is X is yet to be known. Now they say that people that over Bismarck and economics, that is Bismarck and economics, this is where the Bismarck and economics join. So normally, assuming we've known the number of people that over the three subject, we just they gave us 12, that we just minus it from the x, because out of these people that over Bismarck and economics, is out of them that some of them see over accounting also, which make it 3. But here it's only people that are over Bismarck and economics that will be here. So that is why we now say, to know people that are over economics, that over Bismarck and economics alone, will now be 12 minus x. 12 minus x. That is number of people that are over the 2 minus number of people that are over the 3. So we now give us number of people that are over only 2. The same thing happen to here, economics, accounting and economics. Accounting and economics. That is, they give us as 14. So out of people that over economics and accounting, they gave people that over economics and accounting as 14, right? So out of that 14 people, we still have some people that over Bismarck, which make it over 3 subjects. But here we are only concerned about people that over 2 subjects, which is economics and accounting. So that is why we now say that 14 people that over economics and accounting minus x, minus number of people that over the 3. That is how we are going to know number of people that over only economics and accounting. Now same thing goes to here, Bismarck and accounting. They say number of people that over Bismarck and accounting is 8. But out of that 8 people, we still have some people that over both, all of them. So that is why it will now be 8 minus x. So this is how we are going to get into the serious solving. Now the first thing now is to know this one, because what we are going to find now, we find A, we find B, we find C. That is, we find number of people that over only Bismarck. You know, out of these 34 students that over Bismarck, some of them over only Bismarck, some of them over Bismarck and economics, some of them over Bismarck and accounting, and some of them over 3 of them. So this particular people, this A representing number of people that over Bismarck, that over only Bismarck. This B representing number of people that over only economics, and this C representing number of people that over only accounting. Now to get A, that is number of people that over only Bismarck, is now going to be, that means we are now going to add everything within this circle. You know, you say that everything within this circle is this 34. So when we add everything like this, everything within this circle is equal to 24. It will not be it will become an equation. That is how we can get this. We now say it's now going to be a plus x. It will now be a plus x. You know that we are going to add everything within this circle is equal to a. That is what we are going to a plus x plus 8 minus x plus 12 minus x. So it's equal to 34. B. To get this A now, we are going to add everything we need this circle. That is why I just use the same different distance for us to get it right. Everything we need this circle is equal to this. Now say A plus S plus this one is equal to this. Like that is what I just do here. Now when we have this one, we said we have plus x and we have minus x, or minus x. So when you say plus x plus 1, we have negative, we are owing 1x and we have one x. So we use this one to cancel this one. It will now remain a plus 8 plus 12 minus x is equal to 34. Now say a plus this one will now be 20, plus 20 minus x is equal to 34. Right? So from here you can collect the like times, because what we are looking for is A. What we are looking for is A. Now said A a is equal to we are going to collect the like times. When the equation become like this, we collect the like time, that is two things that are in common, they will come together. Two things that are in common will come together, and when we look at this equation, we can see that a and x, there are something in common. Then 34 and 20, there are something in common. Now say a minus x is equal to 34 minus 20. When the positive cross to make the negative to the other side, is going to become negative, and when the negative cross to the other side is going to be positive. So it's now going to be a minus x is equal to 34 minus 20 is equal to 14, right? So a is equal to 14 plus x. So this is our a. So this is equation. It's not, I hope we supposed to have we've done so many equations. So when we get to this level, it's not something that's supposed to be hard for us to get. You say that to get a, which is only people that are over Bismarck, is going to be all this one together is equal to this. Addition of all this one is equal to this. So that's what we just did, that a plus x plus 12 minus x plus 8 minus x is equal to 34. Then we say plus cancel minus, it now remain a plus 8, then plus 12 minus x is equal to 34. Then we say we plug this one, a plus 20 minus x is equal to 34. Then when it's something like this, we collect the like time, that is two things are in common will come together, two things are in common will come together. Then this they have not crossed is equal to, so they have not crossed to the other side, so they are still within. That's why we say a minus x is equal to, this one is positive, when it cross to the other side it become negative. So that's why this 20 will now become negative. So it will now be a minus x is equal to 34 minus 20. So now say a minus x is equal to 14. Then because it's a that we are looking for, so now say a is equal to 14 plus x, that when the x negative, when it cross to the other side it become positive. So now this a now is equal to 14 plus x. 14 plus x. So that is what this a means. Now we've gotten our a right, then we can now solve for b also. B, to get the b2, still the same process. That is to get only number of people that over the economics alone. They say there was the 29 people over economics, but they didn't say 29 people over economics alone. That out of that 29 people, there are people that are over, are students that are over economics alone. There are some that are over economics and accounting. There are some that are over economics and Bismarck, and there are some that are over the three combination. Now we want to get the number of children that are over economics alone. That is, b is equal to, we will add everything here is equal to here. We made the equation and get it just like the way we did this one. Now it's going to be, we get b is equal to b plus x plus 14 minus x plus 12 minus x is equal to 29. Meanwhile, for our information, we can use any number to represent all this. I just decide to use a, b, and you can use y, z, and w. Any number you can use, just to, we are just using it to represent this number of students that are over only this one, just to get this solved. So now say b, here we have positive x and we have negative x, so we can use one to cancel one. Now say this one cancel one, now be b plus 14 plus 12 minus x is equal to 29. It's now going to b plus 14 plus is equal to 26 minus x is equal to 29. Okay? Now we collect the like times. B minus x is equal to 29 minus 26. When the positive cross to the other side, it become negative. Now say b minus x is equal to 29 minus 6 is equal to 3, right? Now because is b that we are looking for, now the b is equal to 3 plus x. When the x cross to the other side, it become negative. So our b is 3 plus x. B is equal to 3 plus x. So that is b. Then the same method we are going to look for c2. Now to get the c, now the c is equal to c plus x plus this plus this is equal to 42. Now the c plus x plus 14 minus x plus 8 minus x is equal to 42. Now we have positive, we have negative. We cancel. Now be c plus 14 plus 8 minus x is equal to 42, right? C plus 8 plus 14 will give us 22, right? 22 minus x is equal to 42. Now we collect the like times. C minus x is equal to 42 minus 22. C minus x is equal to 20. Because the c that we are looking for, now the c is equal to 20 plus x when they cross to the other side. So here c is equal to 20 plus x. Now we've gotten how to get the number of students that over only this one, that over only this one, that over only this one. Now to get everything solved, now we need x. If we see that all the equation is to know all this one, we know that 14 plus x will give us the number of people that over only Bismarck. 3 plus x will give us the number of people that over only economics, and 20 plus x will give us the number of people that over only accounting. Then 14 minus x will give us the number of people that over only accounting and economics. 8 minus x will give us the number of people that over Bismarck and accounting, and 12 minus x will give us the number of people that over economics and Bismarck. Now the problem now is now x. X is what we are now going to look for. So how to look for the x? We are now going to add everything within this circle, everything within this circle, then including this 4, which is the number of people that over any, is equal to universal set. That is how we are going to find the x. Everything within this circle, within the 3 circles, plus number of people that not over any of the subjects is equal to universal set. That's how we are going to get our x. Then when we get the x, everything has been solved. Now say to get x is equal to x plus 8 minus x plus 12 minus x plus 14 minus x then plus 20 plus x plus 3 plus x plus 14 plus x plus 4, which is this one, then is equal to 80, which is universal set. So it has become equation. Now this equation is long, right? Once very simple. Just know that you are going to add everything within itself, including the number of people, students that doesn't over everything. You have to include them because they are part of the universal set and they didn't over anything. And for us to get the x, which is the number of people that over the 3 subjects, we have to add everything within this 3 circle, and this one, including this one, is equal to the universal set. Now, after when we listed everything, what we are going to do is to be reducing the x by using the positive one to cancel the negative one. This is we have positive a, right, and we have negative a. So this one can simply cancel this one, right? Again, we have negative a, we have positive a. So this minus x plus x can cancel this minus x. Then we have positive here, also we have negative here, so this one can also cancel this one. Then after that you can now add together all the remaining subjects. So we now have 8 plus 12 plus 14 plus 20 plus 3 plus 14 plus 3 plus 14 14 plus x plus 4 is equal to 80, right? Plus 4 is equal to 80. So when we add everything, 8 plus 12, that is 20, 20 plus 14, 34, 54, 57, 57 plus 14, that is going to give us 75. So it's going to be 75 plus x. So it's going to be 75 plus x is equal to 80. So it's going to be 75 plus x is equal to 80. You know we're having x here, so when we add everything plus x is equal to 80. Now say it's x that we are looking for, right? Now say x is equal to 80. This one is positive. When they come to this side, it become negative, minus 75. So x is equal to 5. So our x is 5, which we are looking for. Very simple. And once we get the x, we've gotten everything solved. So our x is 5. Very simple. Just follow this method. No stress. So our x is 5, right? So once we get our x is 5, right? So because this one has been rough, we can now draw another diagram to solve everything once. Now after getting this, we've gotten our x, this one and this one. Now we can now solve everything once and for all. We say our x is where, this is where the 3 meet, which is x. It's equal to 34. This is economics, which is equal to 29, and this is accounting, which is equal to 42. Now x, where the 3 meet, is 5. Then we say only a, which represents people that over the Bismarck table, which is 14 minus x. Now we're getting our x to be 5, which is 14 minus 5, which is 9. So we're having 9 here. 9. Then here b, that is the only people that over only economics alone, which is 3 plus, this one is 14 plus x, so that is 14 plus 5, which is 19. Here b, 3 plus x, which is x is 5, that is 3 plus 5, which is 8. People that over only economics is 8. Then here, which is 20 plus x is 5, 20 plus 5, that is 25. Then people that over economics and Bismarck, which is 12 minus x. So it's now going to be x is 5, 12 minus 5, which is 7. Then people that over economics and accounting, which is 14 minus x, right? X is 5, so 14 minus 5 is 9. Then people that over Bismarck and accounting, which is 8 minus x, which x is 5, which is 8 minus 5, which is 3. So then we still have 4 people that are going. So this is how the diagram, because of the small bulb, that is why this one is not that, but we can still get it right. I just try to put everything in a clear picture. So this is how to solve it using the Venn diagram. This is how to solve using the Venn diagram. Now, the question that was asked, that how many students over the 3 subjects? That was very simple. Question 1. 5 students over 3 subjects. 5 students over the 3 subjects. Then question 2. How many students over combination of 2 subjects? How many students over combination of 2 subjects? That one is very simple. That how many students over at least 2 subjects? That is, students are over business and economics, which is 7, plus students are over economics and accounting, which is 9. Then plus students are over business and accounting, which is 3. So when we add everything, 7 plus 9 16 plus 3, which is 19. So 19 students over combination of 2 subjects. So that is all. That is all about this set theory. Set theory is not something to be scared of or something. It's just very straightforward and sweet. Once you know how to compose your Venn diagram, which is not more than this way that we do. Once you know your equation, when you know equation, you don't have any problem on set theory or Venn diagram or any. I will still be doing some other examples, or if you have anyone that want me to solve on this particular one or any related one, just reach me on my WhatsApp number as I stated here, so we can get it done and make it available on this channel also. So God bless you. Thanks very much.